Welcome everyone, and thank you for attending this webinar on how you can accelerate your Maven builds and how you can gain more insights about your Maven builds. My name is Etienne. I'm a VP of Engineering at Gradle, and my main focus is on Gradle Enterprise development. With me is Stefan Oehme. You want to briefly introduce yourself?
Yeah, so I'm Stefan Oehme. Been with Gradle for 3 years now, working mostly on performance-related topics. So I was very happy to jump on in when we decided to do something about Maven performance, and I've been working on the Maven build cache ever since.
Excellent, yes. And we've been doing a similar seminar about 6 weeks ago when the work was still in progress, right? And it feels like it was just yesterday when we sat here.
It gave us a deja vu.
Yes, very much so. But a lot has happened in those 6 weeks. We added more functionality, right? We did a lot of polishing, we added documentation, we verified our product, our functionality against a lot of open source projects and closed source projects as well. And then we finally released 2019.1 last Friday. All right, so what's the agenda for today? We want to give a short overview of what Gradle Enterprise is for those that have not been in contact with it before and why you need it. Then we're going to give you a deep dive into Gradle build scans and how you can get very deep insights with those build scans. And then we'll look at the build caching that you get with Maven, with Gradle Enterprise. And then we'll also look at some best practices. Right? That's always a topic that comes up.
How to actually use it in practice.
Yes, exactly. Yes, and how do you set up your access control, your cache topology, and how you configure your cache and your scans. So we'll share some real-world experience there.
Right.
And then to close this off, we'll also go into the export API. It's an important aspect if you want to do your own data analysis. Right? Cool. And then, of course, we'll give them our audience a chance for questions. Right. So we'll get started with an overview of Gradle Enterprise, but first we want to make sure there is no confusion when we talk about Gradle. So Gradle is the company developing two products. We have the Gradle build tool as well as Gradle Enterprise. The Gradle build tool is open source. It's a tool for build automation. Right. Not much more to say, very well known and used. And then we also have Gradle Enterprise. It's a commercial SaaS product. You install it on premises, and it gives you a very big boost in development productivity, obviously. And you can use it for Gradle and Maven. Right? That's why probably most people are here today. All right. So what is Gradle Enterprise? Gradle Enterprise connects to every developer and every CI machine that builds with Maven or Gradle, or even builds with both of them.
Right, I mean, many organizations have both, either they're migrating or they just have different teams with different preferences. So it's really cool that you can have both worlds.
Yes, yeah. And once you are connected to Gradle Enterprise, a machine, Gradle Enterprise captures all the data about everything that happens during a build execution. For all the builds, all the time, and whether it's on CI or local builds. Right? And all that is captured in what we call build scans. Right? It's a viewable, persisted record of what happened in your build. And that data is also available via the export API. Right? So Gradle Enterprise but also provides a build cache, right? That can dramatically speed up your builds by sharing unchanged code level build and test output across the entire team. Right? And we'll see that in practice and in more detail in a second. Right? This is just about giving you a rough overview and on how Gradle Enterprise is structured.
I think seeing is believing there.
Very much so. Okay, but before we jump into some real demos, just to give you some numbers to give you a feel of what you can get out of using build scans and build cache. So the Gradle team, that's ourselves. Every day we build we have a lot of builds running, right? And within 24 hours we save about 90 days of build time by not having to do work.
Yeah, you have to wrap your head around it a little. Like, how can you save more than a day in a day? But it's the serial time it would actually take combined on all the machines that we have.
Yes.
That we're saving there. So if we didn't have the build cache, basically we couldn't have that many tests.
Yeah,
Like we couldn't ensure as
catch
much
up.
quality because we would just be waiting 90 days every day.
Yes.
I mean, we have lots of CI agents, so, but still, we would probably have a full queue all day if it wasn't for the build cache.
Yep, very much. But we're not the only ones, right? There's like some evidence from Tableau that they were willing to share. So some of their heaviest builders, they save about 1 day a week, where they don't have to wait for the build to finish, and instead they can work on new features instead of waiting for the build to finish.
That's what you want to do as a developer, right?
Exactly, exactly. And if you multiply that with the number of developers they might have, that adds up to a lot of savings as well that you can instead invest in your product. All right. One last thing before we go to the demo is we want to do a short poll on what version of Maven you are using. And even if you don't use Maven at all, please still let us know in the poll. Right, so we'll give you a few minutes to fill that out.
Yeah. It's really interesting to us to get these kinds of statistics. We did that last time, 6 weeks ago, and it kind of tipped us in favor of putting the lower bound at Maven 3.3.
Yes.
Because almost nobody cared for lower versions. And that actually removed a lot of complexity, so we were very happy about that. And we have similar issues with versions below Maven 3.5, so maybe at some point in the future we could also drop support for those old versions. Let's see what people say, what we actually encounter in the wild.
Yep.
But for now it's 3.3. So.
Yep. And generally we are very conservative with giving up on old versions. Like
we
still support Gradle, I think 3.x with the latest build scan plugin, so we don't easily give up old versions.
That's true.
Right? All right. So let's see what comes out of the poll. So about 70% are on 3.3 or newer. About 20% are not using Maven. Glad you're still joining this webinar.
Thanks for dropping by.
Yes. And less than 5% are using Gradle, are using Maven older than 3.3.
Which kind of matches our assumptions.
Yes.
That's good.
Excellent.
Yeah, thanks everybody.
All right. So with that, let's do a quick run through on build scans and build caching for Maven in practice. We'll go into much more detail afterwards, but let's just see the process in action. All right, so what did I have to do to enable Gradle Enterprise? Pretty much 2 things, and I'll show you that quickly. We have to, for one, enable our extension, right? So we hook into the standard mechanism that Maven gives you to extend Maven. And you can see that declaration here, right? So that's our extension.
So that just comes from Maven Central, and everybody can add that to their build.
Absolutely, yes. And then we also have to tell the build where is our Gradle Enterprise server, right? Because as you saw briefly, in the end, the build data is captured and uploaded to a Gradle Enterprise server. And if you use a remote cache, as you will see more detail afterwards, it will also upload it to that server.
Okay.
So we have this little Gradle Enterprise.xml file specific to our extension, where we just define the URL of where our Gradle Enterprise server lives, right? And that's it.
That's simple enough.
Yes, and with that done, I'm just going to call Maven clean verify, which now runs the build as usual. Okay. But since we registered that extension is now capturing data about the build while it's running. Right? And it's capturing that data, it's pooling it to disk, and once the build has finished, it will then upload that build data to the server.
All right.
And once it's on the server, we call it a build scan. Right? So you see it's currently running tests, and some more tests, and now it's done. And what's different to if you didn't have Gradle Enterprise enabled is that you have this URL at the end of the build that tells you a build scan was published, right? So I think we should take a look.
Let's dive in.
So what you see here now is a visual representation of the build data that was captured and is now persisted on the server. And we'll go into more details what it actually is, but I just want to give you a glimpse of that it's captured and it's visualized.
It even seems to know you. It has your face on it.
Yes, it even knows who I am. Right? We'll learn more about this very soon.
All right.
What we can see also very quickly, even without diving into it, is it took 30 seconds to run those goals. Right?
Which is reasonable, I would say. I mean, running all the tests for the Commons Lang project in 30 seconds. Yep. Not a bad build time.
Nope. It's my fast machine. So let's run it again though. And I haven't changed anything.
Okay.
So given I didn't change anything, it would be nice if it didn't do anything.
Yeah. So normally you would expect it to take the same 30 seconds again, right?
Yep.
But it didn't.
Yep. It was much faster. So let's look at how fast it actually was. And what we can see here now is,
it's another scan. This one.
Too many tabs open. So what we can see here now is that the second time we ran it, it only took 5 seconds.
So 6 times faster.
Yes.
And you didn't even change anything else about the project yet.
Exactly.
That's pretty cool.
Yep. So as you can, or as our audience can assume, this has to do with the build cache. Right? That avoids work being done when it's not necessary. Right. Okay, so if we just kind of summarize what has been happening. You've seen the screen before. We have a developer machine, my machine in this case, that's running a Maven build. And while it's running, it's capturing data.
Yep.
When the build's done, it uploads that captured data to the Gradle Enterprise server, where it's stored as a build scan, persisted for as long as we want to. Gradle Enterprise allows me to configure that. And a user can access that build scan and see what has happened in the build. Right. The build cache was also involved. In this case, only the local build cache, but it works the same with the remote build cache, in which case the artifacts would have been stored in the Gradle Enterprise.
Okay.
Right.
We'll talk a little more about the details of that later.
Yes, yes, absolutely. Okay. So now let's take a bit of a deep dive into the build scans. What is it exactly that is captured, that we can see? So I'll go back, to my build scan that I had open, and let's open one more time the one that took 30 seconds to run. I have that here. So as I mentioned, you get a summary at the top. We can see it's a Maven build scan, another Gradle one. We can see who published it. We can see what project we ran, what goals we executed, or what phases, and when it actually happened.
Yeah.
A few more things we'll come to in a second. But there's more than that. I can also see what version of Maven I was using, what version of the extension. And of course, the question that always comes up, well, what switches did you run it with? Were you running offline or not? And so I can also see all the switches, whether they were turned on or off. And I can also see the infrastructure information, meaning I can see in what environment my build actually ran.
So this is really great for debugging. I mean, instead of asking, oh my God, where did you run it? What Java version? What Maven version? What, I don't know, what switches did you use? What exact commands did you run though?
Yep.
All those questions just disappear. It's just, can you show me the build scan?
Yep. Yes, and from that perspective, you could say only the things I showed so far would already be a big value.
Absolutely.
Because what you can do is you can just share this URL to the build scan, or you can just copy it here, share it with somebody else, and then all these questions that you just brought up, they just go away because people can look at the scan and they know what's going on.
So if I'm a developer and maybe I'm not as familiar with our Maven build, I can send this to one of the developer productivity engineers or build engineers, whatever you call it in your company, and say, hey, I can't figure out why this is failing, or I can't figure out why this is so slow.
Yep.
Can you please tell me, am I doing something wrong, or is there some problem with the build,
yes,
etc. And then instead of asking hundreds of questions back and forth, it's just all there.
Exactly. Yep. that's very valuable. Another use case is with CI. If I run a build on CI and it's not behaving as I expected, maybe it's failing, maybe it's passing, or it's slow or fast, or who knows. Yeah. Rather than going onto the box and having a frozen terminal like I just did, you can just get the build scan plugin URL and look at it on your local machine, yeah. And see what has been going on the CI agent.
And you might also be able to spot telltale differences, maybe. Like, oh, on CI it ran under Linux, I'm running on Windows. No wonder there's an issue, or something like that.
We even had situations where it was like a Java minor version or JRE minor version that made a difference, and we were easily able to spot that with the build scan. Yeah. All right. But there is a bit more. So we saw things about the environment, about the switches, about what did I run. I can also get an idea of the project structure. It's a very simple project structure, but very often it's a more complicated one. And I can see the full details here, and we'll see a more complex one as we go on. But even here, what's valuable, I can see what's the group ID, the artifact ID, the packaging type, and the version, and where it's located. Right. Then I can also get information about plugins, which is very interesting, especially when you look at a project you're not familiar with, to understand what is this roughly doing by looking at the plugins.
I mean, just some IDEs give you this feature of seeing the effective POM, where you can look at a POM with all the parents in line, etc., and then you get somewhat of an overview of, okay, that might be the final configuration of this project, but then it's super long. It's very hard to scan, basically, visually, and also it's one project. What if you have 100? Right? It's just pretty unmanageable, and I mean, you have the same problem in Gradle as well. You look at a build that's unknown to you, and you want to figure out what plugins are used, same problem. Yeah. So it's really cool to see, okay, these are the, I don't know how many it is, 20 plugins that this project is using, their versions, which project is using which plugin.
Yep.
It's all there.
Yes, exactly. I can see which project is using that plugin. I can also do it the other way around, and I can say, for a given project, what are the plugins that are being used? Right. Yep, so that's all there. And then what's of course very interesting when you run a build is what goals were executed, right? Or what were part of the build. And that is what you can see on the timeline, what we call timeline. I can see all the goals that executed. I can see as part of which phase. I can see when they started compared to the beginning of the build, and how long did they take. So by default, they're ordered in the way they were executed. Okay. But I can, of course, also say I want to order by duration, and then I can instantly spot which goal took the longest to run. 18 seconds, that was the running the tests.
Right. As you would expect, testing takes a long time, usually.
Yes. And I can also look at more details. I can see if part of which project is it. Also, the duration is broken up some more, and we'll see more about this when we talk about the cache. Right? And I can see from what plugin is it coming from, what's the motor class, and also things related to the cache. Again, we'll see that a bit later. So all that information is available here.
So you can really easily tell what the bottleneck in your build is, and focus on that. Like, we need to get those tests under control, for instance. This is not a crazy amount of time, I would say, but in some projects that we did analyze, we saw tasks where I was like, damn, this, for instance, I think it was some kind of a configuration generator, and all it was doing was starting a whole web server to generate a default configuration file, which had 3 lines. And it took like 20 seconds. And that times 4 for 4 different projects. So the build took 80 seconds minimum just to write 4 files with 3 lines, instead of just checking those files in. So you see that immediately when you have a build scan, but it's not as apparent on the command line, just like, oh, okay, the build is slow,
Yep.
Guess that's normal. I don't know. Maybe it's me.
Yes, and then you might also have different machines, so you can build some different machines, compare the scans, and then also get more input on that. All right. So and then there's the last thing we can show here, that is the performance. So if I want to get a rough overview of where did the time go, I can see the total build time, and I can see how it's broken up between initialization, the project discovery, and then of course the execution of the goals and the calculation of the execution plan, right, and everything else. I can also see the garbage collection time. Right? That's can also give me some idea of memory pressure.
Yeah. So if that goes too high, I might want to check my Maven opts, give Maven a little more memory.
Yes. Yeah. And in general, how was the memory usage? Was I maxed out or not? That's also available for each build. Should the execution plan take a lot of time? I would see it here also broken down by the different projects. Nothing too disturbing here. And then the interesting one is, of course, the goal execution here, where I can see how many goals were run, and then how many were, even though they should be run, were not run because the work can be avoided due to the cache. And we can see here nothing was avoided. All the goals that were planned to be run were actually run, all the 19s.
Right.
So we didn't get any savings from the cache the first time we ran it, obviously because there was nothing in the cache.
Exactly.
But what's already interesting and promising here is we can see that 3 of the goals were actually cacheable. Meaning,
that gives us hope.
Yes, meaning they could use the cache, they could use cache artifacts if they were present. Right, and if we want to know which ones those are, we can also navigate there and then get an idea. Okay, compile, and test seem to be cacheable goals. Right. But still, they were run, and as we said, it took a long time to run the tests in this run.
Right.
Okay, and then the build cache tab. We'll get to that a bit later. Now let's take just one more short look on the second scan, which was the second run I did, which had the cache being effective. And what we can easily see here is some goals were taken from the cache. Right, so let's open the timeline. I can see some have from cache. We can do better though than just glance at it like this. I can just say, give me all the goals from the cache. And I can see also how long they took. So using the artifacts from the cache just took 1 second.
Yeah, so compared to the, I don't know, 26 aggregate or something like that.
Yep.
So we saved 25 seconds on that.
Yep. And that's something in general that is valuable, that I can always search for the things I am interested, whether it's the goal or it's the phase. I can narrow that down as well. So if we just look at, let's take the compile taken from cache, without going into much detail because we will cover it too, but we can see it had a hit. It was using something from a cache. Right? To just say as much. And just to prove or close that loop is I can also go to the scan that actually produced the output that we consumed. Right? So now we're back to our first build, which put something in the cache, and then the second build was able to consume from the cache.
So if there's something wrong, maybe, God forbid, but there is a cache hit even though there shouldn't be one.
Yep.
Maybe I forgot to declare some input. I can check, what went wrong here? Who put that in the cache?
Exactly. So so when we talk about debugging, that is a very important feature to understand. Who put it in the cache and who consumed it. Right. And this is behaving as expected.
Really
All right. So that's what we have here in store.
And I can even share like this filtered down view that you just did, right? So it's all in the URL.
Yes, as everything in this scans URL is we have deep linking. So if I want you to look at this because I'm wondering why did I have a hit, I didn't expect it, I can just copy that URL up here, and when you open it on your machine, it will show exactly the same state with the search, with the inspector being open.
Cool.
So you can really pinpoint versus saying, well, go to the scan and then manually drill to this goal and so on. Right? That's what we can do here, right? I can also do it like this, and then it opens like that on the recipient's machine.
Cool.
Yep. So if we are on that last scan that I showed, we also have the build cache tab, and that is just another kind of source of information to see, okay, we had 3 goals that were taken from the cache, how many were from the remote cache, and lots of statistics around it, right? That help you also understand, is the cache performing as it should in terms of networking?
Is it helping me, or is there some problem? So if something went wrong, you'd see it here.
Yes.
Maybe you're not authenticated. All kinds of other things that could go wrong.
Yes, exactly. It's not only for the good case scenario, but also for the case where things go wrong. It will tell you what went wrong, or if you have a very bad network speed, or something like that. Right. Okay. So with that, there's only one more thing I want to show, and that is we can also customize those build scans.
Okay.
Right. But actually, before I do this, to make one more addition, as we said, sometimes something goes wrong, and then we have a failure, right? We also have support for that. So if you have a failure, you will see that which goal failed. Down here was the check style goal that failed, and we can also see, there's a classic one.
I remember that build. I was trying to make a little change, be like, I'm just going to do a print line in here to force the compiler to rerun, and check style plugin was like, you can't just put print line in our code.
Nope, not allowed.
Are you crazy? So yeah, very strict code base.
Yes. And then the build scan tells us as well, and it's a good way to then inspect what was actually going wrong, or to share this with somebody else. Something we don't have yet, but we'll have in the next version. So I'm going to show it just briefly with a Gradle build scan. Is that we capture all the tests,
right?
And then you automatically see them ordered by duration. You can also search for them, so I can see what are the Kotlin tests that ran. I would also see the failed tests and so on. Right.
So it's much easier to find out like what are my badly behaving tests, because there's often this cost-benefit calculation that you need to do with testing. Yes, you want to catch bugs, but you also don't want to spend all your time waiting. So.
Exactly. So So where do you invest your time?
Right.
That goes here, and we do this across all projects. So if you have 100 projects, this is an aggregated view. You can also then see it per project. It's all there in one report, and not in 100 project-specific reports.
You don't need to read 100 files.
Yes. And the very last one is the dependencies view. So of course, super valuable. You want to understand your dependencies. So let's just search for. I'm going to go to one project. Let's take Findbox. And then we see the dependency and where it's used. We can also go and see who requires it. On this one, like how is it being pulled in, right? And what does it depend on, which is nothing in this case, right? So you see this across all projects, the full dependency tree, and you can search for any dependency.
Also, if there were any conflicts and how they were resolved and so on. So
yes, you would see that as well.
That's really cool. I mean, the bigger your project gets, probably the less of an idea you have what your dependencies really are. So seeing it like that is super helpful. Yep.
Yeah. So that's coming in one of the next versions, just like the tests.
Awesome.
Yep. All right. So the last thing, as I said, that I want to show is how do you customize build scans with your own data? If we look at this scan here, it contains a lot of valuable data, but maybe I want to annotate it with my own data. Maybe add some links or some key value pairs and so on. So I want to show this briefly using another build. So now I just need to make sure I'm on the right project. Okay, so I have again Commons Lang, but this time I've checked it out locally because I wanted to add some custom values. So for that, what did I change? Again, I had to go into the Maven folder. we have the extension defined. That's like before. And now it gets interesting. We also have the Gradle Enterprise XML defined. But this time we see there's more in there than just the URL. Right? So let's look at it in a bigger screen. So what I added here is some information that is static to this project. Okay. Like I wanted to mark it as being a webinar, right? For lack of a better example.
Maybe you have some experimental projects, or some projects that maybe, I don't know, follow special rules that you want to filter for.
Yes, exactly. So the tagging, of course, then helps with the filtering, as we'll see in a second. I also added a link. In this case, it's a static link that just points to the webinar itself. And I also added a custom value, and that's why that experimental type comes into play. So I used the custom value. Because sometimes if you just use a tag, the tag itself, the value doesn't tell you what it stands for.
You want a key.
Yes.
Yeah, makes sense.
Yes. Okay, so if I now run this build like we did before, clean verify.
So that means I can add additional information to my projects so that the build scan really stands for itself, and somebody looking at it doesn't even need to look into my repository or go to my homepage, or I don't know, ask a colleague, hey, do you know something about that project and where their website is? Or
yes, exactly. Then it becomes all self-contained on the scan itself. Yeah, on the scan. So we see this here. We now have this tag, which I had declared in the XML. I also have a link with the label. So if I click here, it's going to open the webinar sign-up page. Right. And I also added a custom value, which is this project type, which is called experimental.
Awesome.
Right. So I can add any kind of data here that I want to. Right. But so far, what we've seen is it's all static data. Meaning we cannot change it based on the state of the project or whatever it is. So let's do that as well. So what I did for this is I had to go into the POM, and I configured the Groovy plugin, and I'm pulling in a Groovy script.
Groovy to the rescue when you need something dynamic, right?
Yes, exactly. So I'm pulling in this file because I want to add some conditional or dynamic logic. So if I now open this file, I had it commented out because I didn't want to see those values already, but I'm going to comment it all in now.
Again, it's a little small.
Yes. So. We can see that I can get an API by saying session.lookup. And then I can have my logic, whatever it should be. For example, I can say, well, if there's an environment variable, then that is CI, then I want to set a tag called CI, otherwise a local tag. Or I can call git because I want to get the status and add that as a custom value. Or I can even go as far as capture the diff, which is just a bit more logic, but it's nothing specific to Gradle Enterprise. In the end, it just creates a diff and uploads it as a gist. Right. So let's run our build again.
Okay. And I should mention this API that you injected into your Groovy script there. That's actually also available to normal binary Maven plugins. So they can use add-inject or add-component in their plugin implementation, and then get this build scan API and have a statically compiled plugin that adds additional data.
Yes.
So you could, for instance, run it during the validate phase of your project or during the verify phase or whatever, and just add more data to the scan.
And also makes it easy to share, like within your company.
Right. Instead of saying you need to copy paste this Groovy script into your project, you just say apply our special plugin that adds the git diff.
Yes, and then it's maybe a company-wide thing. Great. Yes. So a lot of reusage that way as well. Okay, and what we see now with those custom values is now I have my tag here called local because, well, I didn't have a system environment called CI. I also add a custom value that gives you the status of Git. And as you can see that I added 3 new files. Git doesn't know about them. And I also changed the POM, so it's modified. And as a last thing, we also have the diff here. So if I click on this diff, it now takes me to Git. To a gist that I uploaded to GitHub.
Just so cool. I mean, imagine you're troubleshooting with a colleague and you don't even need to ask them to tell you what they changed. You can just look.
Exactly, and it's all there.
Yes.
Yeah. And that, whether using Git or some other tool or GitHub or some other tool, that is not, that's just whatever you code in your Groovy script. Right. Okay. So that shows the customization of your build scan. And to wrap up the build scan part, there's also the scan list. Here you can see all the scans that were captured. And you can already do some analysis with that. I can say, well, how many builds do I have in the system? You can see that down here I have 426 builds. I can also say, well, I'm only interested in the Gradle builds or only in the Maven builds. Let's go with Maven. And then I can see how many, 171. Right? Or I can say,
we were busy.
Yes. Or I can say, how many builds did fail within the last 24 hours, or how many builds fail per week. I can do that here. Or I can say, we had that here before, I can say, I want to see all builds that have this tag called GE Maven Webinar. Right? And if I now search for it, now I see only those builds. Right? So it allows me to easily filter those builds that I'm interested in. Of course, it also has sorting, so I can see the longest builds and so on.
So that ties back in where we said you might have different categories of projects that maybe follow different rules, and you want to have like more, there's more critical projects maybe, where you want to be like, oh, the failure rate has gone up a little, that's very bad, and then you have maybe some side projects where you're like, whatever, figure it out yourself. So that really helps.
Yes, to track that down.
What the problem is.
Yeah, or if I'm interested in, well, which ones were failing from you?
All my blunders.
I can see there were 3 failing builds. But of course, it's not about kind of blaming people or spying on people, but it's more like understanding, okay, does a certain build fail more often locally than remotely, or like on CI or so.
Or is there maybe something wrong on my machine, like is my setup broken? And I'm just, I might be just swearing at the build, and meanwhile you see that and you already know, oh yeah, that's that problem, we already know it. I'm just gonna call my colleague and be like, hey, no problem, just do this. And then I'll be like, oh yes, you just saved my day, and I didn't even ask yet. I was still busy swearing. Because that's what we do, right? We don't usually ask right away. We fight the machine for a while.
Yes, very much.
So,
so that is the scan list aspect that already gives you some ways to do the data analysis. All right, and so with that, it's now time to look at the build caching aspects.
Let's do that. So before I dive into the demo, I'll just give like a very quick overview of what the build cache does. Because we've been talking about this thing and wow, it makes things faster, but what is it? So the build cache caches the outputs of goal executions. So in Maven, you have projects, and projects apply plugins, and plugins can have different goals. For instance, the compiler plugin has 2 goals that are called compile and test compile. And then these goals can be executed in a so-called execution. So an execution might say, run the compile goal and run it during the compile phase of the project. So that's like the default when you have a jar project. There's a default mapping in Maven that says, if you build a jar, then you run the compile goal during the compile phase. But you can run it multiple times. For instance, you could compile for Java 8 and 9 and then merge the 2. So then you would have 2 executions running the compile goal, and both of them during the compile phase, one after the other. So that's the level of granularity where we hook in. We take this execution before Maven can actually go and run the execute method of that goal. And we look at all the inputs. So that might be the source code, that might be some parameters like, do you want parameter names in your bytecode? Which Java source level do you have? I don't know, do you want debug symbols in your bytecode, etc.? So all these inputs, what Java version are you on? What Maven version are you on? Which version of our extension are you using? And so on. all these inputs are combined into one hash key. So this is of course using a strong hashing algorithm to avoid collisions between different executions. Right?
Yep.
So it's very, very, very unlikely that you'll ever get two things that hash to the same thing, and both of these things are actually something meaningful.
Yeah.
I mean, there's a lot of garbage that would hash to the same thing, but you're not building garbage, so that's okay. So once we have that hash key, we can go and ask the build cache, hey, have you seen this before? So just send it in a local cache. So there's two caches. There's a local cache and a remote cache. In the local cache, we just look on your file system. Have we seen this key before? In a remote cache, it'll be an HTTP request to the remote server being like, hey, do you know this key? And if we do, then all we have to do is download and unpack the result and then put it in your output directory. And then we can just skip the goal completely and just say, hey, just came from the cache, all good. Now, if we haven't seen it before, then we'll execute it as usual and then store it in the cache after it's done. So we take a snapshot of all the outputs that you just created and then store them in the cache under that key. And again, you can store things in a local cache that's on your machine, on your file system, for very fast access. But you can also share things in a remote cache so that your teammates and your CI machines can all benefit from shared outputs. And we'll get into like the details of how to ideally set up a caching pipeline and so on later. But this is the gist. So every goal execution is potentially cacheable, and the logic for making them cacheable is currently part of our extension, and in the future there will also be an API for you to make your own goals cacheable.
Do we do this for every goal?
So right now we do it for compile, test compile, surefire, and failsafe. And we also support Jacoco for code coverage. That doesn't have anything expensive on its own, but it adds additional inputs and outputs to surefire and failsafe. So we need to track it as part of that. So we saw in your example, Commons Lang going from, what was it, 30 seconds down to 5. We have more of these kind of spectacular examples with 5x, 10x, 20x speedups, but I thought I would use a more somber example where we only get the 2 times speedup. Just to set the expectations right, it's not always gonna work perfectly. Sometimes you will have a build where there's just some goals that are not supported yet and which take a really long time. And either you can optimize the build or you'll have to wait for more goals to be supported. So I just wanted to show that too. So what I have here is the Apache Maven project. You might have heard of it. I've checked out the 3.6.0 release tag, and I'm just gonna build it normally.
And regarding what you said about the only 2 times factor, I mean, if the build takes 30 minutes and it goes down to 15 minutes, times n builds a day, that still adds up to...
That is still amazing. I'm just setting a 2x speed up as a bad example. Yes. Because we can do so much better in many cases. But I didn't just want to show 10x speed ups because then someone might get disappointed. All right, so the Maven project, this is actually the core, like the Maven core project basically. It's relatively small, so it contains the basic API for writing plugins and the basic machinery to run a build. So it's a relatively small project, has fast running unit tests, so it just takes 40 seconds to do a clean verify, which is reasonable, I think. So as a first step, I'm gonna apply our extension. So I'm gonna enable caching. Do the same thing again. Now,
so you enable the caching the same way we did it
yes, so
in the build scans example?
Exactly. I'm not going to show that again. I just added the same extension XML file and specified our server. So now I'm going to run it. My local build cache is currently empty, so I should see a somewhat similar execution time, maybe a little slower because I'm storing things in my local cache for later reuse. So there's always a little bit of overhead if you want to save things later. There's always some cost, but
like the packing.
Exactly, packaging it, analyzing of the inputs in order to calculate the cache key takes a bit of time. So yeah, there is an overhead.
And we do show that in build scans too, right?
Absolutely. We're very open and honest about our overhead.
And we've seen cases where that took a long time, right? Because of a slow disk or tons of inputs. And so it's good to know.
Absolutely. So I have my first build scan. So I have my build scan. It took about 50 seconds. So there was a bit of an overhead, which we can see here. I packed 1.5 megabytes of stuff into my local build cache. Let me just make that a little bigger maybe, like this. I stored 41 things, so 41 goal executions. And if we look at the goal execution tab, we can see 41 were cacheable, so that's the 41 that I stored. None came from cache because, well, my cache was empty. Otherwise, everything looks as it normally would. So there was not much time spent in the execution plan, not much time initializing. It was all just executing.
Yep.
All right, so let's run it again and get a 10x speed up, or not.
So if it didn't scroll so fast, would we see whether it's loading something from the cache?
Yes, so we do realize that you might not always be able to look at the build scan right away, or that sometimes you just need to work on the command line. So yes, it also tells you on the command line whether something came from the cache or not. And it also gives you a little summary at the end of the build that I'll show in a second. By the way, we're running this on a CI server right now to be independent from any things going on my machine, because I'm currently screen sharing. So these are somewhat realistic numbers of how long this would actually take on this server, on a real machine. So we have this little summary that we added to the Maven default summary, which is we had 260 goals in total, 230 of which were executed, 30 came from the cache, saving us at least 6 seconds. Now, this is kind of under-reporting, I would say, but that's intentional. So we don't want to over-report. So what we do is we just sum up all the savings and divide them by the number of processors that you used for your build, and that's the minimum you saved. It's probably better because your build probably doesn't parallelize perfectly. So yeah, usually you'll get a better speed up than that. So it's not that great. I expected more. What's going on here? So let's look at the goal execution tab again. 30 came from the cache. That's nice. But 11 were cacheable, but still executed, even though I have just run the same build before. So that's sad.
And that's also, I would say, a typical reaction that we've seen.
Absolutely
people hear about the build cache from Maven, they enable it, and then like, oh, I only gain 6 seconds out of 40 or something, or 45. What's going on?
Right. So that's a common first reaction, and I kind of want to take that fear away a bit. So this will happen in your project, most likely. The Apache Commons Lang project is kind of a exceptionally well-behaved, reproducible build that has no unstable inputs whatsoever. So it just cached perfectly out of the box. Very uncommon.
So I was very lucky that I took that project.
Absolutely. So we can see here, this was actually a total of 20.5 seconds that we just wasted. Right? And we can see the first thing that didn't cache was Maven Core. So maybe we should look what happened there. So if this was a a Gradle build, I could already use a feature that we have yet to add to Maven scans, right? So I just want to show what the normal workflow would be once Maven scans also support this. In the Gradle build scan, you can compare scans. So you can just go, hey, I have these 2 builds, and I don't know why all these tasks rerun. And it'll tell you, well, the source property changed. More specifically, something in subproject's core source main Java changed. More specifically, it was cache repository services.java. And the same goes on and on for all the projects that transitively dependent on that. So
here you're comparing the 2 builds.
Exactly.
The one you ran first and then afterwards where you expected to have all these cache hits.
Right. In my build B, I was expecting to get all the cache hits, but then I forgot, oh yeah, I changed this file. So no cache hits for me. So yeah, this is what we would wish we would have right now, but we don't yet. This will come. So what we've built instead is some logging that you can enable in order to compare things on the command line. So that's what I'm going to do right now. So I'm going to run Maven clean verify again, this time with this SLF4J configuration that says, hey, please log all the fingerprints of those goals. So the fingerprints are all the normalized paths, all the normalized content hashes. So normalization means we don't take everything into account for the hash key, for the cache key. So for instance, the absolute path of your input files doesn't really matter. What matters usually is the project relative path. For many tools, not even that matters. Many tools don't even care about the name of a file, they just care about the content. So we can normalize the whole path away and just forget about it. And the same goes for the content. For instance, the Java compiler doesn't really care about implementation details of upstream dependencies. It only needs the signatures. Like when you write foo.execute, then that execute method needs to be something public or protected, or maybe package private if you're in the same package. It can't be something private. So we can strip out all those private things, for instance, from your upstream libraries. So we can ignore a lot of unimportant stuff. And that's what we print out here. So
regarding what you just said, a question that sometimes comes up is, well, but what if I use reflection?
Yes. Well, the compiler can't use reflection.
Exactly.
At runtime, of course, all these details matter. Like, of course, fields matter, methods matter, method bodies matter. Almost everything matters at runtime, except for comments because they're gone. But almost everything else does. So at runtime, we use a different strategy. So when you looking at the inputs for tests, for instance, we use a strategy that takes all those details into account. But when we look at the inputs for just compiling, we can strip out all that stuff. Great. And we'll also see that in action a little bit later. So I've run Maven once with the fingerprint logging. I've run it again to another file. And now I'm going to do a diff. And that shows me, okay, I had different cache keys here. Why did I have different cache keys? There was a file called Maven core target classes blah 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 build.properties, and that had a different content hash between those two builds. And then if we look down in that trace, we see that file showing up again and again, and then later we see the Maven core jar showing up as a changed file, which makes sense because this changing file was in the Maven core jar.
Yep.
So it would make sense that the Maven core jar is then also considered different.
So it has like a ripple effect?
It ripples through. So everyone who depends on Maven core, which is a lot of projects here, now needs to be retested.
Yep.
And recompiled potentially. So let's look at this build properties file and what we might do about it. So what do we see here? Build number. Okay, that I think is the git commit, which is already problematic for caching because it means my cache keys are different in every commit. Don't really want that. and a timestamp. That's the classic. Yeah, the current time. I don't know what this is for, because it doesn't change the behavior of the tool, and it doesn't tell anyone looking at the tool anything. So this is one of my pet peeves. I really don't understand why people put timestamps in their output. I can understand the git hash somewhat as a traceability feature, but I really don't understand the timestamp. Anyway, so what do we do about this? There's different things we can do. What I opted for is just moving this to the release profile. So basically assuming the project maintainers, they want to keep this information, they really love their timestamps, but it's only necessary for builds that are actually published.
Yep.
So what I did is I just took this plugin and I moved it to a release profile so that it's only used when we actually do a release. And all the developer builds and the normal day-to-day CI builds now no longer have a timestamp. That gets rid of this difference. There were a few other inputs that were problematic, like absolute paths. I can show you the full diff of all the changes that I did and walk you through them. So I'm not going to do this whole diffing all over again right now. So I'm going to check out step 3. South Park reference intended. So when we look at the diff to step 2, one thing I found was in the Surefire plugin, it was passing the project base tier as a system property. Now the system property will be in the cache key as an absolute path, which means if you build this in 2 different machines or in 2 different folders, you suddenly have a different cache key, which you don't want. Luckily, this property is set by Surefire by default during execution, so it's not necessary at all. Just remove it. Probably some historic artifact.
Yep.
Yeah. So the build number Maven plugin is next. I just removed it from the normal build flow, and instead I put it into a profile called Apache Release. This is a profile that already existed in other POMs in this project, and I just said, okay, only put the build number in there when we're doing a release. Yep. So we won't get cache hits on a release, but we don't do releases all the time, especially not locally, so it's fine. And then there was another property called local repository, which I could replace with a standard property that Surefire also sets. So that was another absolute path that was added unnecessarily. And last but not least, there is an annotation processor, which collects all the, I think it's all the things that can be injected. So it's like the dependency injection framework that Maven uses internally. They collect that at compile time and create like a little descriptor file that says here are all the things that can be injected so that they don't need to do a class path scan at runtime, which speeds up the whole Maven startup. So smart idea. So what I did there is I explicitly declared this as I want this annotation processor. Coming back to this idea of, hey, we only need to look at the signatures on the compile class path. Well, the Java compiler has this default behavior that if you didn't specify annotation processors explicitly, but there's some of them lying around on your compile class path, then it's just going to use those. What that means, though, is that we can't do that trick with forgetting about all the details because an annotation processor is actually run during compilation. Yes. So now suddenly we need to consider your whole compile class path fully, including all the method bodies, which gives you much less cache hits. So I don't want that. So I explicitly declared it as an annotation processor. And now our extension knows, okay, this is fine. This is the only one that will be used. And everything on the compile class path is really just there for the signatures.
Yes.
So, yeah, and then there's this Maven repo local property that I mentioned, which I just replaced with the default property that Surefire sets anyway. All right, so there was a whole profile that did this, which is no longer necessary. Which means now we should get a much better experience.
Now it gets interesting.
Yeah. So The first build will be slower again because we just changed a bunch of inputs. So it should take a little longer. But then the second build, now that we've removed all those volatile inputs, should be much better. And you can really get used to fast builds. It's one thing that I notice right now. It's just 40 seconds, but still, watching it is painful. And I mean, we've seen projects like Apache Tommy, which has a 1.5 hour clean verify time. So,
especially when you know nothing has changed. Then
yes. So we saw roughly 40 seconds again, and now we're running it one more time. And now things should go much faster. And we're at the assembly phase, which is the last step, 19 seconds. So that's 41 from cache. You might remember that number. That's the number of all cacheable modules, goals in this project. So we can't do any better, and we saved about 21 seconds. So that's the best we can do, which is half the build time. It's cool. And the goal execution tab tells us, yep, nothing that was cacheable was executed. All good. Everything came from the cache.
Excellent.
Yeah. So one final thing that I want to show in this demo is what happens when I change something. So I'm going to look at Maven Compat, which is a downstream project. It's like the last project in this project hierarchy. So if I change some little detail here, let's say I just reorder a private field, just put it down here, then I would expect that I get a pretty fast build. Because nobody depends on it, except for the distribution. And I only changed one of those internal details that I talked about that really don't matter for compilation either. So I should get really fast build up until Maven Compat, and then just re-execute those tests. So here are the Maven Compat tests, and here are the Maven distribution tests, because the distribution depends on it. And there we go, 38 from cache, still saving 16 seconds. So we still have a much faster build, 27 instead of 40. And we can look, there were 3 that were executed. It was the Maven Compat compile, Maven Compat test, and Maven distribution test. And you can see Maven distribution had no compilation because we only changed the private implementation detail here. So it doesn't matter for its compiler. And you can see when you look at it, okay, it took 2 seconds to run. It took a tiny amount of time, 6 milliseconds, to analyze the inputs. It took more time to actually store it or try to load it, because it did try to load both from the remote and local cache. So that's these 700 and something milliseconds. It tried to load it from remote. And, well, that's probably further away from this machine that we're running on, so it takes longer. And it was both a miss locally and remotely, and I stored it in my local cache because I had remote store disabled, so I just only stored it locally. So that much for a caching demo.
Great.
Shall we get into best practices?
Yes, absolutely. Before we do that, let's do one more short poll. So we've seen which goals are cacheable, the compile, test compile, surefire, and so on. But what goals in the audience build take the longest to run? We would be interested in that because, like you said, we want to make more of the goals cacheable.
Absolutely.
We also want to provide a mechanism to make custom goals cacheable. But of course, the more that works out of the box, the better. So if you can just answer our question here in the question box, that will be excellent. That would help us a lot, and we'd be curious. And if all your goals are fast, then let us know as well. Then you're in a good situation.
Yeah, then you're in a happy place.
Yes, absolutely. And while that's happening, I think we can already
let's move
proceed
on.
And maybe come back to it during the Q&A. All right, here we are. So we also measured a few other projects, like open source projects that we can share here, where we looked at, basically did what you did, right?
Yep.
We looked at it before, and then we looked at it when it's fully
we had
cached.
to make quite a few adjustments sometimes.
Yep.
Some builds were really had lots of volatile inputs. So it really shows that when you don't think about like, is my build reproducible? Like, can I produce one for one the same outputs again? Then you'll also get a little trouble with caching.
Yes.
It's because it's not one for one the same thing, but being reproducible really helps with caching.
Yep.
The cache has mechanisms that allows you to ignore changes. So even with a build that's not perfectly reproducible, you can still make it work. But if it is, like with Commons Lang, well, then caching is a no-brainer.
Yep. But I think there's also a strength of this caching implementation, that is, it can deal with those real-world situations where, okay, sometimes there is something in there that would be nice not to have, but since you have it, we want to deal with it. We need to deal with it.
Exactly.
So it's all there. Right. So maybe not. We don't need to spend too much time. I think the numbers speak for themselves on what you get from the cache. So
and the Tommy example is particularly interesting. So it took 1.5 hours to run a clean verify without the cache, and after quite a few improvements to the project, like removing randomly generated inputs, it's down to 20 minutes. And those 20 minutes, funnily enough, is just the test setup and teardown phase. So we cache the test goal, but the setup and teardown phase or lifecycle phase, they have goals bound to them that say start a Tommy instance and stop the Tommy instance. So most of the build really spends, I think, 15 minutes or so starting Tommy and stopping Tommy 200 times or so.
Yeah, wow. So that would be a good improvement to take that logic out of the goals and put it into the actual test suite.
Right. If they made it a JUnit extension to start and stop Tommy, then it would be inside the control of the cache.
Yep.
And then they could reduce their build time even more.
Nice. Great. Okay, so let's talk a little bit about access control, best practices in general. We'll start with access control and then look at some of the other ones. So I'll just go briefly through the access control ones. So Gradle Enterprise allows you to enable access control, or IAM as we call it, and you enable it in the app replicated console of Gradle Enterprise. And once you've done that, then you have a whole new application available where you can configure or administer the application. Gradle Enterprise. You can have local users like we have here. You can give them roles or permissions. You can also set up external identity providers. So I could select an LDAP provider or a SAML provider and then configure all the details I need.
So it just hooks into my existing company infrastructure. You just say everybody in that team can push to the cache.
Exactly. Actually, it's more about like who can view scans. And who can use the export API, and who can administer the cache.
Okay.
The cache access we'll see in a second.
All right.
So this is how you can configure it. And then if we go to the cache administration that you just mentioned, I can go without spending a lot of time on how I navigate there. But at some point, I can define what are the users and their passwords and what are their access rights to the cache.
Right.
And the reason we didn't specify anything in our Gradle Enterprise XML files is that we also configured an anonymous user that has read and write access. Of course, in a real setup where you have access control, you would probably set this to none, and you force the users to authenticate in order to read, write, or both. Right. This also allows you to make sure that maybe that your cache instance is maybe not used by a different team, because you're kind of worried that the cached output would be shared with somebody that it shouldn't be shared with. Right? We've seen this in practice as well. Right. So that's the other part of access control. And the last one is the build scans themselves. whether you can see the list of all scans, whether you can see a single scan, you can also give that permission. Right. Typically, people can see the scans, but not necessarily can they administer the cache or write to the cache. Right? You might also only configure CI to write to the cache and read from the cache, but as a local user, you can only read from the cache. Right? So that's how you set up this access control. Right? And that's pretty much all I want to say at this point about access control. You want to say a few things about the benefits of modularization?
Yeah. So there's one thing that we learned while looking at these open source projects, it's that I think 8 out of 10 roughly were either single module projects with, I think the craziest was 1 million lines of code in one project. Most of this was SQL, so it was just like example data, but it was still like 200,000 lines of Java code in one module. And then all the tests as well. And the other projects were modularized a little, but then all the integration tests were at the end in a single module. And of course, that doesn't benefit very much from the cache, because anything that you change will make those integration tests rerun. So if they're all in one module, you're not going to get a good bang for your buck. So one good counterexample was the Tommy project. They really separated things pretty well. I think the Glassfish was it the Glassfish project? No, Jetty and Tommy. They really separated these things well, so that when I made a little change over here, all the integration tests over there were still up to date and could just be fetched from the cache instead of rerunning. So that makes those builds really fast. Even though they take, I don't know, an hour or so to run originally, we can get them down to 5 minutes because they're so well structured.
Yep.
So that's also a takeaway for your own builds. Modularize, if you
and
want.
not just the tests, but also the production code.
The production code, the test code. Especially modularizing tests and staying away as much as you can from these I test the whole world tests. I mean, you need a few of them, of course, to make sure that everything works together. But testing everything that way is really costly.
Especially when you do it on every build.
Exactly.
All right, that's a good one to remember, right? Modularization. Then we have a few words about build cache topology. So Gradle Enterprise ships with a cache controller and a built-in node. And the built-in node is really the thing to remember as a user, because that's what we connected to. We didn't configure any address of a cache node. We just gave it a G address, the Gradle Enterprise address, and that was also giving us access to the node. But what you can do is you can set up additional remote nodes. You can actually set up a whole topology, a parent-child topology. And that is very useful, for example, in scenarios where your people are distributed, or your CI that populates the cache is in a different location than your developers.
Right.
Even at Gradle, we have this situation. Right? We have people across the world. We have people in Australia. CI is somewhere in Germany. And so by having remote nodes, those people working in Australia, they get access to their node, which is much closer than if they had to go to Germany every time.
And I connect to the Frankfurt cache node and get fast results immediately. So
So so here the good practice is to have your nodes, your cache nodes, as closely to where you are as possible. And this is even leveraged by the fact that we have what we call replication and preemptive replication, meaning if your node doesn't have it, it will check another node, its parent node, whether it's there. And if it's there, it will pull it from that parent node. So it takes even longer for the build to decide, yes, I need to rebuild it. Because if the node doesn't have it, maybe its parent or its parent will have it. The other one is the preemptive replication, meaning as soon as a node has a new entry, it will push it to its children. So if the people in Australia wake up in the morning, their cache is already populated with whatever was put in the cache somewhere else on CI overnight.
So they're just productive right away in the morning. That's perfect.
Yes, and if you have tasks like, for example, Webpack or so that might run 10 minutes in our environment, you save the 10 minutes in the morning. Okay, that's build cache topology. How about the build cache configuration? Who pushes and who reads?
So I already explained there's a local cache, there's a remote cache, and you can store and read from both. So by default, we disable storing in the remote cache because, well, it's shared with everyone, so it better be safe to pull from that. So just like you don't share your local Git state with everyone, you don't push to the master branch without checking, hopefully. We also recommend not to push to the remote cache from your local developer machines. Instead, what we recommend is that your CI server pushes to the remote cache when it builds your master branch or whatever branches you have. And then your local developer builds or other CI builds that are downstream from the first one, they can pull the results. Which means, as you said, when you come to work in the morning, CI has built all your colleagues' changes already, and you just do a Maven verify or Gradle build, and it's just all from cache immediately. So you can just get started coding in the morning.
Excellent. That's and maybe just to emphasize, so another reason to not push the remote cache as a developer is it's also very unlikely that somebody can reuse what you just put into the cache.
Because you probably have local changes that nobody else will do like that, so it doesn't really make sense to share that with everyone. And worst case, you have a virus on your local machine, or and you really don't want that to propagate through your company.
Yes.
So CI is the way to go there.
And we also have a short graph for this, so you can see the developers, they read and write from the local cache, that's local to their machine. They pull from the remote cache, but they don't push the remote cache, and then CI does both. One more thing about best practices is like, we saw this Gradle Enterprise configuration in the project, but what if you want to overwrite this for your environment? Or
so we allow you to specify this in many different ways. You can put it in your Maven installation, which is the lowest precedence. So that means you can have like company-wide defaults. You can have a custom-built Maven distribution where you put in our extension and you put in the default Gradle Enterprise XML and share it with your developers, and they can just get started. They don't even need to do anything in their project anymore.
So like the Gradle Enterprise server could be configured in the Maven installation of their company.
And you could reference that with the Maven wrapper script. It gets even easier. They just reference your custom distribution and everything just works, no extra files required. The next one is in the project directory. That's what you showed. So any project-specific settings take precedence over the installation. And then the last level is the user, because the user knows best. So if they say, well, really, I'm going to use the Frankfurt cache node, I don't care what the project says, or I don't know, I'm disabling this or that feature because I don't like it or it doesn't work on my machine, whatever. Then they can put that in their user home, and that will take precedence over everything else.
Excellent. All right. That gets us to one last thing that we want to show, and that is the export API. So we saw all the data that is captured by Gradle Enterprise. We can see these build scans, but there are situations where people want to pull that data into another system. Maybe they already have their data warehouse or some other event-based system to process the data and draw some analytics from it. Or maybe they just want to create some fancy graphs and dashboards that are very custom to their needs. So it would not even make sense for us to build those, because every customer has different needs of what they want to show and how they want to show it. So you can pull out the data and do with it pretty much whatever you want to in processing and visualizing it. And you can do it in two ways. You can just say, give me those builds and give me the events of those builds and do something with it. Or you can also have real-time streaming, meaning you can say it's all based on server-side events, even if you don't do real-time streaming. But if you do real-time streaming, as the builds come in, you can instantly consume them. That they're pushed to you, and you can update your dashboards.
So you have like live graphs.
Yes.
Awesome.
Yes. So let me show you a short demo that we've recorded. That I'm going to start right here. So what we see is we have a build that is run 3 times in parallel, or it could also be different builds, doesn't matter, but they all point to the same Gradle Enterprise instance. And here we see a dashboard that we built. That's just running in a browser. There's no backend involved in that sense for the data. And it just listens to the export API via
so it's just like some JavaScript that subscribes to the export API?
So that the JavaScript supports that, the server-side events protocol in the browser. And now we see some builds are running, and as these builds are running, some builds show up. And we see how long they took and whether they failed, red, or if they passed in green. And so a few more builds are coming in. And the dashboard is updated live. So you could have that running all day long, and you would see how this is developing. You see now we're accelerating the build or the movie at least, and you see all those builds coming in, and it shows you some pattern. Of course, it's very easy to just show the build time, or very basic, but it's already giving you some indication. And you could measure number of test failures, you could draw which tests have failed, and so on. Which tasks take the longest to run.
That's also really cool for prototyping. I mean, if you can just prototype it in the browser, get the live events, you immediately see what you're doing. It's awesome.
Right, so that's something you can do with the export API. So to wrap this up, what have we learned? We've seen how you can really highly accelerate your builds with Gradle Enterprise. How you can make them more reliable, how you can debug your builds. We even did some debugging. And how you can do your own data analysis via the export API. We just saw a glimpse, but there are other webinars we've produced that go into much more detail on that. The same with the CI pipeline optimization, with the cache and so on. We have a separate webinar for
and
that
both
as well.
really applies to Gradle and Maven. So even if those webinars were about Gradle, the exact same concepts apply.
Yes, absolutely right. Yeah. And all this applies to all builds, to local and CI, Maven and Gradle, doesn't matter. You want to learn more? We have a few links. Since we're going to share this, I put them right in here. If you want to try out the build scans for Maven for free, one can just go to scans.gradle.com, run a build. After applying the extension, that's it. You don't even need a Gradle Enterprise.xml file. Right? So it's super easy. And then run Maven clean verify, and you get, or whatever you want to run, and you get your scan for free as a service from us. We also wrote a blog post recently on how you can use the build scans and build cache for Maven. We have a manual. There's more documentation, or just contact us if you want to have a personal demo, right? Which we do as well. Right. What's coming in the next version of Gradle Enterprise? The next versions, I should say. We mentioned it already that you can cache your custom goals as well. That we provide a DSL for that, and that we provide more goals with caching out of the box, Java doc check style and so on. More Maven build scan insights, mentioned that, tests, dependencies, right? Also build comparison that you showed for Gradle. We were also going to have that for Maven.
That would have been a great help. Tracking down those issues.
That's invaluable. To compare the goal inputs, the executed goals, comparing infrastructure to see differences and so on. Right. And then also performance dashboard, like we saw it.
We didn't show that part.
Actually, we didn't show that.
We can show that real quick, if you want. Can you just switch me over to presenter?
All right, just to give you a taste.
I'll just show you a quick taste of a performance dashboard.
Yes.
So
far, all we've seen is single scans and the scan list, but we haven't seen what happens over time.
Yeah. So the performance dashboard allows you, just like the scan list you showed, it's exactly the same search criteria, to get an overview of how well your builds are performing. So what we see here is, what's your average build time for a build? How long would it take serially? So that means how much on average do you speed up your build with parallel execution, basically? How much on average do you save per build? So we have about a 90% cache hit ratio. So, or I should say savings ratio, which means we save about 13 minutes on every build on average.
Yeah.
And if you click on here, it shows you the total for the time frame that I'm looking at, and that time frame is just the last day. And you can see that the total is 90 days of build time saved.
Yeah. And so that's also a very good instrument to really quantify the savings you get with the cache, and also to justify to other people in your company the value of making your build as cacheable as possible.
Exactly. And you also see the build cache overhead. So you see if anything's wrong, like, you know, if you have lots of cache misses, that overhead will go up. So you want to make sure that you stay at 95, 99, whatever percent ideally. And then down here, you actually get a list of all the scans in a little timeline view. So you can page through them and see, maybe spot some outliers.
Yep.
And they're colored the same. So saved times in gray. So you can see that almost all these builds were basically did nothing. It just all came from the cache. And the gray bar shows you how long it would have taken if the cache wasn't there. So these are our own builds. This is like a live view of what's happening at Gradle. So you can imagine how much more we would be waiting if we didn't have our own build cache.
Yeah. And we would also spot regressions.
Right, so we look at this number regularly and we see, okay, is our savings rate still where it should be? All right.
Yep, so that's just a glimpse at the performance dashboard. We'll show it in more detail once we have it from Maven as well, which is surely coming soon. And of course, in Gradle Enterprise 2019.2 and future versions, we are also adding more features for the Gradle users. Right? We're not just abandoning the Gradle users; we're just extending the user base to all the Gradle and Maven users. Right. So with that, we're at our time. But if there are some questions, I think we can still take.
I think we have time. Yeah. So if there's questions, let's see them.
So one question was, is there a way to manage the extension version centrally? For Gradle, we use a global init Gradle script to control the version of the build scan plugin. We would like something similar for Maven.
Yeah, so that would be the custom distribution approach, where you package the version of the extension that you want in a Maven distribution, and then you use the Maven wrapper to point to that distribution.
Yep.
And you can, you can make that URL changing if you want, I guess. Although that's not a good idea for reproducibility, so I wouldn't do that. So I'd rather have like a versioned Maven distribution, your version of Maven, with always the right version of the cache extension packaged in.
I think so.
But still have the projects themselves pinned down to one version of your Maven distro.
Yep. Can the .maven folder be externalized on the CI agent so that scans can be enabled globally rather than adding it to every single repo?
Well, kind of the same idea here. One second. So we already showed that you can have it in user home, in the Maven installation, and in the project dir. So I would probably apply the extension to every project just to have it pinned down to a version that works well for the project. And then you could say, okay, I want to activate it just on CI. I have like in your CI user home, or with a command line property, you say always publish a scan. Although always publishing is on by default. So and really you want the local builds.
Yes.
You want to see them, because that gives you so much insight into what your developers are struggling with, where the problems in your build are. So I think a better example would be, how do I enable storing in the remote cache only on CI? Because that's really a best practice. So you would be able to pass a custom configuration file, or just a system property for the single thing for enable remote store.
That's something we didn't show, but you can configure all these things that are in the Gradle Enterprise XML file also via system properties.
Yeah. And you can configure the location of the whole file with a system property. So it's super flexible.
Yep. So somebody upgraded to Gradle Enterprise 2019.1.1 and ran a scan for a Maven project, and said it wasn't accepting those Maven scans. Yeah, so this is a very new feature, and it's not enabled by default. But if you are a Gradle customer, you can get in touch with us, and then we can enable that feature. Right. Yep. Are you planning to add Diff views to Gradle Enterprise itself? It seems that those SCM changes should be working out of the box, as they are useful for everyone. Yeah, that's a question that comes up repeatedly, also internally. The whole VCS integration, and we would like to do it because it will also help with other things like flaky text detection and so on, when we know the state of version control. But we haven't given it the priority needed compared to other features, because there is a way around it. Like you can do what we currently do.
And there's so many providers, like, where do you upload the diff to just GitHub or to Bitbucket or to,
Yes.
So it can quickly explode in scope also.
Yeah, probably, but I think this person will probably assume that we have an integrated diff view even into Gradle Enterprise.
Yeah.
We could do it, we would like to do it, we probably will do it at some point, but since there is a way around it right now, we focus on other things that there is no workaround for it. Right? Yeah. Okay. And what happens with a build scan if I'm working offline, and how large are the scan files? Do you want to say something about offline?
Sure. So offline, right now with Maven, you just don't publish a scan. But in Gradle, we have a feature that we will also support in Maven soon, which is that you can publish the scan from the last build. So that if you were offline and then you were like, damn, should have been online and published that, you can just say, hey, go and publish the last scan.
Yes.
And how large are the scan files really depends on your project.
Yes.
You have more experience with those sizes, I think.
Yeah, it very much depends on the size of the project, right? And the size could be how many tasks you run, how big the exceptions are, how many tests you run, how many dependencies you have. There's so many factors in there that, but what I can say is that for every customer, we have some really big customers with really big projects, we are able to handle the size with the performance you expect to take on these scans, to store them. We do a lot of deduplication to optimize storage. So even if you have very large scans, through the deduplication, each scan does not take up a lot of extra space.
Yeah.
Right? So it's very optimized for storage.
Basically, we only store the events that are actually different from something that that we have seen before.
Yeah. Mm-hmm. And maybe we should also say that if you're offline, the local build cache still works, right?
Right. The local build cache will keep working. Like we check the license once a day, but as long as you have like a valid token still locally, the local build cache will keep working.
So you can get on a plane and keep working with the local cache until you're connected again.
Keys remind me of Jenkins fingerprints. I assume it is a similar mechanism. I mean, the similarity is, it's probably an MD5 checksum that Jenkins uses, but that's pretty much where it stops. So there's, I talked about all this normalization, where we take out all the unimportant details of the input. And so that really gives you a key that's actually useful. Because if we just took a hash of all the absolute paths and all the contents down to like jars, for instance, when you package things in them, those things get their last modified time saved in the jar metadata.
Yeah.
So unless you have like a reproducible file time as well, jars are not reproducible byte for byte. There are ways around this, like at least in Gradle, you can say, give me reproducible jars, and then Gradle will set the time to 0 for everything. But yeah, so if we just said, let's just take a straight up file hash, that wouldn't work well. So there's a lot more smarts in it. Let's say like that. Yeah.
And we can benefit from all the experience we have with caching for Gradle builds, which has been going on for probably close to 2 years now. So all that knowledge, the experience, the improvements that are also available from day one in Maven, because we're reusing most of it.
Exactly.
Most of the smarts. Fixing cacheability of a single goal shaved off 20 seconds of build time. Are there any tricks for identifying those goals breaking cacheability of multiple other goals?
So you usually notice when you just read that diff from top to bottom, like you see, like with that build properties file, you first see it as an input to the tests of the project itself. So you know, okay, something in that project is changing. Then later, you see it as, like you see that project's jar showing up as changed, which kind of tells you, oh yeah, because that file has changed. So basically what you do is you start fixing that log from the top. And then you just rerun. And then what usually happens is you fix one issue and then 1,000 downstream issues disappear. Okay.
Next question. As you only switch private variables, nothing should have changed, as none of the public interface changed. In my opinion, nothing should have compiled.
Well, the project itself needs to compile because I changed the source code.
Yeah.
So the bytecode will be different if you change the order of methods. So that, but only that project that recompiled, nothing else, because the public ABI has not changed. So all the downstream projects were unaffected. And maybe that comment is about private variable order shouldn't matter, but it does. Like if you use reflection and say get fields, and then you do something based on that, like logging or whatever, the order is there. Like it's exactly the order in the source file is also in the class file, so it does matter.
ETA on making things like Avro or protobuf cacheable.
No ETA.
Yeah, we have no ETA.
But we will work on making things cacheable out of the box, like check style or JavaDoc, things that a lot of people use. But we will also be working on APIs to make your own things cacheable. So either the Avro or protobuf teams could use those APIs to just support it out of the box, or we could create an even more advanced API that allows you to say, well, that plugin over there isn't cacheable, but I know how to make it cacheable, so just let me do it.
Yes.
So, yeah, I can't give you an exact ETA for that, but but eventually you will be able to work around any cacheability problem.
Yeah. And it's like everything we do. It's a continuous effort.
Right.
We make things better. We add new things, and so making more goals out of the box cacheable is going to happen.
And if this is something that's useful to a lot of people, like if we see Avro protobuf being used widely, then why not make it out of the box?
Yep. Is OpenID Connect support for identity providers on the roadmap? It currently is not, because we have no customers right now that are asking for it. SAML, of course, is highly requested. So is LDAP. But we can support OpenID as well if the need comes up. Right. Is it possible to publish our scans in a local or custom server instead of Gradle's cloud servers? Yeah, absolutely. So the moment you specify Gradle Enterprise server, that server lives in your closed environment.
And so it's an on-premise product, like you install it in your environment.
Yes, and all the scans go there. By default, the cache, the remote cache, is on that instance as well. Nothing goes anywhere in our cloud. Right? The only thing where scans are published to our servers is when you use the free service, scans.gradle.com. And then you don't even specify a G server. You just specify the extension, and that's it. Right? The same service we have for Gradle side. It's for free. You apply the plugin, build scan plugin, it publishes there. But of course, for like an enterprise, you want to have the confidentiality and keep it in your own network.
Okay. What about Maven profiles, like our integration test profile? Will that cache? Since the cache is not based on projects or profiles, but on an individual goal executions, that doesn't matter. So as long as the goal executions inputs are the same, and that goal is supported, of course, like the failsafe goal, failsafe integration test goal is supported, it will cache.
Yeah.
All right.
All right.
Thanks
so
a
we're
lot.
through
Great questions.
with the questions. Thank you very much for attending this webinar. So there are a few actions you can do, right? You can just try scan-stack-gradle.com, or you can read some of the tutorials, or you can follow some of the videos, the webinars that we already did. And that's it for today. Right.
Thanks a lot, everyone.